Thank you so much for the introduction, and thank you for inviting me to give this small talk. I hope I will not disturb your lunch too much. So it's only going to take a little while. But let me try to share my screen here, see if we can make it work. I think I have the presentation here, and then I have to make it so that I can see myself also the screen. All right, are we good in terms of the PowerPoint? So super, thanks a lot, Megan.
Yeah, let's go.
So yes, I'm going to present some work that we have done over the years in terms of the indoor climate in schools, not so surprisingly considering what TAPAS is dealing with. Of course, with a focus on Danish schools coming from Denmark here. We've done quite a number of studies in schools over the years, and also some rather large studies, and I'm going to present some findings from these, what is it, since 2009, 13 years of studies. Oh, we just need to focus here. So there we go. So a few words about schools in Denmark. We have, we used to have more schools, but the number is decreasing as schools are merged, mostly because of economy and because people move from rural settings and into cities. So it's around now, it's around a little more than 1,200 schools in Denmark, with around 500,000 pupils and around 56,000 teachers. So many people, like you know, of course, spend a lot of time in these buildings each day and during, especially for the pupils in their younger years. If we take a look at the school buildings in Denmark, this is a cumulative curve where we have the construction year on the horizontal axis down here, and then we have the percentage of the total area. And we have a cutoff at around 1900. So even though we have a few schools or school buildings that are older than these 122 years, they're not shown here. But we see that after the Second World War, in the late 40s, then the number of schools, or the square meter dedicated to schools, started to increase. Then it levels out, and then it increases again in the 90s. And then I can't see the upper right. Now I can again. So we're at 100% here. So all the schools, when this curve was made, that was in 2012. The interesting thing when we look at a curve like this is in relation to the building code here in Denmark. We have different generations of the building code, and I'll just show one of them, the building code from 1995, which was the first to specify ventilation criteria and air quality criteria for schools. And if you look at this, then we say 1995, and where we have the intersection here, it means that around 90% of the school buildings in Denmark were built before we had these requirements. So that's sort of the offset for the rest of the story that I'm going to present here, so that our schools were not really built with ventilation in mind, which it is, or they would be today. We're not building very many schools in Denmark. On the other hand, actually it's the opposite. Schools are, like I said, they're closed, and sort of pupils are condensed in fewer schools as it appears right now. Okay, another thing that we benefited from in this work on indoor environment in schools is what we call mass experiment, and it's a large-scale experiment that is designed to engage pupils in the sciences, different types of aspects of science. So it takes place every year, and it involves a lot of pupils and schools. They sign up themselves for participation in this experiment. And in 2009 was the first time we did it with a focus on the indoor air quality in schools. And what you see on the image here is the pupils trying to get to know not the instrument, but the equipment to measure the carbon dioxide concentration. They have this syringe, and they have a measurement tube that they connect. Sorry, see some messages here on my screen that just needed to move. They connect the measurement tube to the syringe and then use that to measure the carbon dioxide concentration. The first time we did this in 2009, We had around 800 classrooms in close to 300 schools in Denmark, and then some additional schools in Sweden and in Norway, where they did exactly the same type of measurement. Just one of the results here, the CO2 concentration. We see the pie chart. So if we go from this bluish color, that's where we would like to be, concentration below 1,000 parts per million. And then if we go in the clockwise direction, then the concentration increases up to between 3,000 and 4,000 parts per million in these schools. So this was the maximum concentration that we could measure. And actually, this very pie chart generated quite some media attention and political attention, because it shows that less than half the schools in Denmark had an air quality that corresponded to the criteria or the guidelines that we usually use for air quality in schools. Then, I have to go to the other Scandinavian countries first. We have Denmark down here, southern Scandinavia. These are the results from Denmark. We have Sweden up here, and these are the results from Sweden. Much better than in Denmark. 84% of the Swedish schools had an acceptable air quality when we use the carbon dioxide concentration to estimate that. Norway, almost the same as in Sweden, slightly worse. So we have focused mostly on Sweden, and they have the same criteria, but they have a different way of managing the indoor environment in their schools. And almost all schools in Sweden, they have a mechanical ventilation system. So not surprisingly, the air quality was better in Sweden and also in Norway. So we didn't perform very well when we compared with the other Scandinavian countries, unfortunately. But that was an important result, also an important outcome of the study that was also used to put some pressure on the Danish politicians, both on the municipal level and in Parliament, to do something about this. Then we repeated the study again in 2014. It's like you've seen this picture before. We made the same measurements, CO2, temperature, and also airborne microbial fungi. They measured. I'm not including results of that. And then used two different situations. One where the pupils did as they usually do in terms of airing the classroom, and one where they were told to leave the classroom during the break and air out the classroom, and then come back and then do the experiment in the following lesson. And this was the results from 2009. And remember, now we had all this attention from media and politicians who promised to do something about this. And then 5 years later, this was what we had. And you really have to look carefully at these two pie charts to see if there's a difference. So a slightly lower percentage of classes in 2014 than in 2009 had an acceptable classroom air quality. Okay, then the idea, if it was 2009 and 2014, there was an interval of 5 years. But then if we were supposed to follow this, we should do the next study in 2019, and it would be with the same interval. We were a bit slow and planned it for 2020. But in 2020, schools were empty in Denmark, like in most other European countries, so we couldn't do it. So we did it in 2021 and added some elements that we didn't have before. So we wanted again to follow up on the previous studies and see if there had been a change in the succeeding years or the years from 2014. But then we also wanted to be a little more ambitious and then include the pupils in the loop so that they also could express how they felt in terms of the indoor environment. And we would try to measure the concentration performance again in the two situations when we aired the classroom and when the pupils did as they usually do. So that's the rest of the presentation is mostly about showing what came out of this study in 2021. So the design, we had 2 days again in 2 successive weeks, and we carried out the study in November and December last year, which means that was during what corresponds to a typical winter scenario in terms of window opening, when we told the pupils to do that as they usually do. That's what we call uninstructed behavior. They were supposed to keep the windows closed during the lesson, But otherwise, they could do that before the lesson where they made the measurements. They could do what they want. They could go out in the break before the lesson, or they could stay in the classroom. So don't think about what to do. And then the other day, we told them again to leave the classroom in the break and to carefully air out the classroom. And then again, keep the windows closed during the experiment lesson. And we try to do, I mean, this is, with such a large number of pupils and classes, it's difficult to be present in all the classrooms at the same time. So we relied on them to do that. So we lost some control, of course, but instructed them carefully what to do on the 2 days. And then we tried also to balance the behavior on the 2 days. So half of the classes first used the uninstructed behavior, and the other half of the classes first used the instructed behavior, and then they shifted on the second day to try to balance or to avoid bias from following a special order of the 2 behaviors. So one of these we call as usual, and the other has been labeled with airing in the figures that I'm going to show in the coming slides. What we did was at 2 different levels. We had measurements, again, of the indoor environment in the classrooms, and then we had a simple building checklist. And it had to be simple because it was completed by the pupils and the teachers, so we couldn't be too specific on the building, but we had some key questions that we wanted to, or key properties that we wanted to have some information on. And then with the pupils, we had an online survey of how they perceive the indoor environment and the intensity of different symptoms that have been related with the indoor environment. Then we had a short online task to measure their concentration performance. So first, in terms of measurements, we measured the air quality the same way, because that was our main outcome, you might say, our main measurement. That was to compare the measured CO2 concentration with the previous years to see if anything had changed. And then we measured the temperature. We also sent them some equipment to measure the temperature. And remember, this was also an experiment that was made to stimulate the interest in science. So we tried to make it a little more detailed to measure both the radiant temperature in the classroom, so an integrated surface temperature, you might call it. And we did that with a ping pong ball with a temperature strip attached to it. And when the ball was held in still air, it measured the globe temperature, and when it was moved through the air, when the pupils waved the ping pong ball, then they measured the air temperature. So that was more like a gimmick to measure these 2 temperatures. Lighting was measured with a cell phone. We all have cell phones today, and they have different apps. So before we did the actual study in schools, we tested different apps in parallel with our equipment to measure lighting, and selected an app that we recommended the classes should use. Then we measured the noise level or the sound pressure level, again with apps, one app that had been tested. And finally, there was another app to measure reverberation time, but that was again because it would be fun, because they had also some balloons we sent to all the classes so that they could pop the balloons. That would be a noise source, and then they could measure reverberation time. But that's not really supposed to be measured with a classroom full of pupils and with a high background noise level. So these measurements were not really very high quality, so we haven't really looked into them. But it was also, again, to stimulate the interest in science. Then we had a questionnaire with perceptions. In this case, it's we ask if it's too cold, and we used these emojis because we had classes going from all the way from preschool and up to high school, and high school pupils are able to complete this, but preschool children are not able to complete a written questionnaire. So questions on perceptions, on symptoms like headache, and then we made this small test with a simple question about this geometrical figure, like for instance a triangle is smaller than the circle, and they had to indicate if this was true or if it was false. So they had 24 statements they had to deal with as part of the exercise here. Okay, let's take a look at what came back in. So if we take at the class level, there we had measurements and we had the checklist. So we had the measurements from little more than 600 classes, with and without airing, or as usual and with airing. Then we had the checklist from 640 classes, and when we combined the classes, it's always about if we have the checklist from the same classes who made the measurements, but then we ended with a little less than 600 classes. At pupil level, we had questionnaires from 21,000, a little more than 21,000 pupils, and when we combine those data with the classes that made measurements and completed checklists, then we had around 7,000 questionnaires, a little more with as usual and a little fewer with the airing behavior. Close to 21,000 concentration tests, and when we combine everything, then we had complete data from between 6,000 and 7,000 pupils who participated on both experiment days. So quite a considerable data material, although it wasn't as high as we planned for. We invited many more schools, but it was a little messy because schools were also sent home in 2021 from time to time. So there was some disturbance. Teachers were rather stressed during this period with all the other things they also had to deal with. So the first thing, again, the CO2 concentration, you have seen these pie charts already, and then we add 2021. So, well, this can be discussed. Is it an improvement or is it not? Not a lot, at least. It's still less than half the classes that measured an acceptable air quality in the classroom. So it wasn't too impressive. Then if we look at the type of ventilation, in 2021, we had 4 different categories. We had no mechanical ventilation, meaning they had to open windows to air out the classroom. And then we have observed in when we have visited some schools, they had the ventilation system installed, but it was not running because either it generated too much noise or it caused the draft in the classroom. So it wasn't running. They told the janitor to switch off the mechanical ventilation. Some of the classes had exhaust, and some of the classes had a balanced mechanical ventilation system. Now, in the previous years, we didn't have this category, mechanical ventilation installed but not running. So if we say that's the same as no mechanical ventilation, then we end on 40% of the classes in 2021. 2014, also then, the results generated a lot of political attention. We actually had meetings with parliament members in parliament to discuss this issue, and nothing has happened in the 7 years that went from 14 to 2021. If we include 2009, then it seems that fewer classes, after all, have to rely on natural ventilation, and more classes have a balanced mechanical ventilation system. So a little shift from ventilation only by natural means, but that's typically by manual opening of windows in the classes. What does it mean? These 2 behavior patterns that we instructed the classes to do. Now this is a fairly busy slide, so it's a box plot where the line here is the median concentration. We have the 75 percentile and 25 percentile, and then we have the whiskers indicating where the outliers would be. So these are sort of outliers for this type of ventilation. So with classes with a balanced mechanical ventilation, this is not new. This only confirms what we know already. So with balanced ventilation, the CO2 concentration, not surprisingly, is lower than with the other system, and we see a little effect of airing out the classroom. So if we go from the usual behavior to this airing behavior. And then if we move right in the diagram all the way to when the systems are turned off, or when we have dedicated natural manual ventilation, then we see why we have this poor air quality. With more than 40% of the classes not having a balanced ventilation system, this is not surprising. But we also see there's a huge effect of airing out the classroom. So we can do something through behavior, at least when pupils and teachers have their attention directed towards doing so. But it's what we have seen when we have tried this earlier is that over time, these good habits tend to disappear. So an effect of the ventilation type and an effect on the air quality of the behavior pattern. When we look at their perceptions, first of all, there wasn't such a big difference in terms of the usual behavior and airing behavior, but the small difference we see goes actually in the right direction. If we The low value here means that a perception is stronger, they have stronger discomfort, and a high value means less discomfort, maybe counterintuitive, but that was how it was coded. So when they're airing out the classroom, they feel colder than when they have their usual behavior. Not surprisingly, they feel warmer when they have their usual behavior than when they have the airing behavior. That's a two. We had to split it into two different scales because it was difficult for the youngest pupils to consider both being too hot or being too cold. Draft, a little more draft when they were airing out, but the most significant, the largest difference between the two conditions was here the perception of the air quality, which was much better when they were airing out the classroom. Again, as expected, but it's nice to be confirmed when we do something like this, which is actually not entirely out of control, but it's not something that we are controlling tightly in the classes. And then the noise a little higher with the airing behavior, and then lighting just a modest difference. When it comes to symptoms, yeah, all the symptoms improved a little bit. Some of them were even significant when we adjusted for the age of the pupils and the gender and the type of ventilation. But again, some modest differences in terms of the symptoms. But things seem to be moving in the right direction. And what was even more interesting to us, because we didn't know what to expect from doing presenting the pupils to a concentration performance test. We haven't tried this at this scale before. But actually we saw that the airing behavior meant that the number of errors they made was 6% lower when they went out. Whether it's then that they are moving out of the classroom, running around, breathing some fresh air outdoors, or if it's the ventilation, increased ventilation during the break, better air quality in the classroom, that's difficult to say based on this experimental design. Not surprisingly, high school pupils perform better than the lower elementary school, so they made 42% fewer errors. And then finally, girls perform better than boys and made 20% fewer errors in this case. So just to round off, so this was an experiment that dealt with airing of the classroom and leaving the classroom. So not surprisingly, it improved the air quality, and we quantified that by the carbon dioxide concentration, and that improved their perception of the classroom, improved their intensity of these symptoms that we see in buildings, and then reduced the number of errors in the concentration test a little bit. So that was what I wanted to say. So let me stop sharing my screen here and see if there's anything coming. I see some things moving in the chat, but I haven't been able to to deal with it yet. But of course I'm available.
Yeah, thank you very much. Yeah, so I think we should do questions now. So yeah, there have been a few questions in the chat. Maybe we can look through those.
I can open the chat. Yeah.
Yeah. So so Chris, do you want to ask your question?
Yes. Yeah. That's these are spot values. So it was just as all these measurements were spot measurements, except for the noise level, the sound pressure level was measured during the whole lesson, and then they reported the mean value during the lesson. And then the next question is if that's a.
Could you read out the question when?
Sure.
When you answer them, just
yes,
so that other
of course.
people...
So the first question that I responded to was: are these CO2 values spot values or daily averaged occupied CO2 values? So they're spot values during this made at the end of this lesson when the measurements were made. And Kate asks: is it usual for windows to remain closed during lessons? Have you surveyed uninstructed behavior? It is usual for windows to remain closed during lessons. We see that again and again, not during the warmer period, so around from April, May, and until September, early October. There they may open the windows, but then on, that's from October and November, December, and then January, February into March. That's when we see the challenge. Windows are not open because the outdoor air is too cold to be, I mean, in addition to flush the room with fresh air, then those who are sitting close to the windows, they feel the cold air, they feel draft, they feel cold, so they ask for that to be closed. We have not surveyed the uninstructed behavior in this study, but we have done that in other studies where we have visited schools. We had measurement equipment, and we have had sensors on the windows and doors so that we could follow when they were actually open. And it's not very much. It's a very brief period, sometimes in the breaks, but definitely not during the lessons.
There's a couple more questions in the chat. Chris Idden has also asked, are there any, in 2009, are there any significant difference in school test results between well-ventilated Swedish and Norwegian schools compared to Danish schools? And school test results, we're always competing with Finland. Actually, I don't think so. It goes up and down a little bit. If we are discussing PISA test results, we haven't compared those across countries. We have tested in Denmark. We both have the PISA results, which tests across the European Union, I think, and then we have our own what we call national test scheme, and we have had data from these two test schemes and merged those with the data that we have from the first two Mars experiments. Actually, it was only from 2009 because we have some information on the school buildings, and we had some measurements that could be representative or not. So we didn't see an effect of what we measured because it was probably too few. But if we use the type of ventilation, if it's a school building with manual natural ventilation, or if it has a balanced mechanical ventilation system, then there was a difference in the performance of the national test scheme when we adjust for socioeconomic status and a range of other parameters that we could include in the statistical models. But I'm afraid I can't say anything about the comparison with Swedish and Norwegian schools. That might be a good idea to try to see if we can team up with Sweden and Denmark. And Norway to compare that. So Mark is asking, could you give more details about the concentration test and the extent to which it gave a valid reflection on the concentration levels that would be required of children in a normal classroom activity?
That's also a very good question. We have used this test quite a number of times, both with adults. Then it's usually just a statement. It's not a geometry issue they have to deal with. But we had to make it simple. I have to say that most of the pupils were able to respond to this. But if it reflects the concentration levels that would be required, then I think they're probably more focused when they're taking a test. So I think it not normal classroom activity, but normal test activity, and what they're exposed to with all the tests that the pupils today seem to be exposed to. So it is a test like many other tests, and probably not a situation where they are learning, which I consider a normal classroom activity. But it's a test that has been shown to be sensitive to exposures from the indoor environment.
So Christine has asked, did you look at any respiratory symptoms during the study?
Not in addition to what we asked for. So I guess the answer would be no, we didn't really deal with that. But that might be a good idea. But it's always a compromise between how many questions and how much time you can keep them occupied, and the time that is available. So we filtered out a lot of questions that we would like to know, and then focused on those that we have seen most often is an issue. That's headache, tiredness, eye irritation, nose irritation, and mucous membrane irritation and skin irritation. Those are the most prevalent. Whereas respiratory symptoms are often connected with allergy and asthma. And of course, it's relevant, but would probably be. I mean, we didn't. That's the short answer in this case.
So one last question is Nicola has asked what was the concentration test? How was the concentration test administered? So was it computer based? Yes, it was. It was an online test. So we did it like this. The same was the questionnaire. So the class. The school had an ID and the class had an ID,
And then the teacher within the class assigned an ID number to each pupil so that we could follow them from the one day to the next. So they were asked to enter this pupil ID when they took the test. So that's how we kept track of who completed the test. That's often how we do it, except when we work with lighting and daylight, because when you're looking into a monitor, then for instance daylight does not have very high influence. But otherwise, when we are doing experiments with thermal exposures or air quality exposures, then we use online testing.
One last question. Is your research on like the test results versus different ventilation types published anywhere?
Yeah. Actually, we just submitted a paper on this particular experiment. It has not been through review yet, but in the earlier paper, this with the test schemes, the national tests and the PISA test has been out for some years. I think it was from 2015. So I don't know if you have some kind of a storage. So then I could send it to you, Megan, or maybe to Kat, if you have somewhere to share it. Would that be a way to do it?
Yeah, well, I guess we could share it with. Let's share a link with where the video is shared.
Oh, yeah, but also if there is a publication, so it's more like the paper, if anyone is interested.
I said it was the last question. Let's have one more question. So, what's your next steps? So, continue to measure or adding air cleaners and other mitigations? Yeah.
We do some work on air cleaners, not so much in schools, but air cleaners in general, because they have really had a revival. They have been in the periphery for many years. They're efficient in removing particles, but that's more like filtration. When we're discussing air cleaning, then there has been some unwanted side effects from the processes that take place in air cleaners. So the components, what we call bioeffluents that are coming from us people in rooms, they generate some new and other, even worse components with the processes, the cleaning processes that have been used. So that's something we have tested over time with different air cleaners. But with all the COVID, air cleaning has had a strong revival because then we can clean the air without ventilating. How it's going to work in a classroom, we're starting to see some results, but it's difficult, I think, if you put an air cleaner in a corner and the pupils are sitting spread out across the classroom, how it can be efficient in the back of the room. Ventilation air, after all, is distributed, if the system is designed appropriately, is distributed in the classroom. And there was a recent Italian study actually that showed that in schools where they had a mechanical ventilation system, the risk of having 2 or 3 cases, that's what they call an incident, COVID incident, was reduced by 80% by doing that. That's one of the earlier studies I've seen in schools, not with air cleaning though, but with the effect of ventilation on the risk of transmission of COVID.
Well, thank you very much. I'm sure everyone will join me. Thank you for such a clear and interesting talk.